So you're a developer and you're building an application, a server-side application to be specific. This server-side application processes customer payments. Naturally, you have a bunch of boilerplate code to handle the HTTP requests, but we're not too concerned with that here. What we are concerned with is the actual method to process the payment. This method has multiple responsibilities, which includes authorizing and capturing the customer payment as is standard in two-step payment flows, amongst other things which we'll get into later. But the real question is this method in its current state testable? Well, what would happen if we actually called this method in a test? We'd pass in a test param, which is an email, which will first be parsed. Then inserted into a structure that will be used in a separate method to retrieve the user associated with the email. But that separate method actually has some problematic behavior for our tests under the hood. You see, this customer package that contains the method actually comes from the Stripe SDK. And Stripe is the payment gateway that we're using to process payments in this application. If we dive deeper into the code for this method within this package, we'll find that this method is actually calling the Stripe APIs internally. So as you can imagine, every time we run the test, we'd need to send a request to the Stripe APIs. But the problem is we're using a test user, which is essentially a dummy user to run the test. So how would you solve this problem? I'll tell you what we should not do. We should not start adding dummy users to our actual production users on Stripe. A better approach would be to decouple the code that handles retrieving the user from our process payment function altogether, and we can do that by extracting it to its own getUser function that takes in the email as a param. This function can then be called separately, and we can pass the resulting user into the process payment function in our actual code. Now, when looking at this getUser function, you'll see that the type returned from this function is stripe.customer. So in our test, we can create a dummy user of this type without ever calling the Stripe API and pass that into process payment in place of the user email. And obviously, we'd need to change our process payments function signature to take in that particular type as the user. And from there, we can simply use that user throughout the function. Now, there's a name for what we just did, and it's called dependency injection. That is, we've injected the user dependency instead of inlining that functionality within the process payment function. And that's the first law. Use dependency injection to decouple components where it's useful. But wait, there are still parts of this function that need to call the Stripe APIs internally, which means we'll still run into the same issue when trying to test this function. But what if we could actually completely decouple the Stripe SDK from this function altogether? And what if we could do it in such a way that we could literally unplug Stripe's SDK from our function when the code is not running in a production environment, and instead plug in a dummy or mock payment gateway implementation when the code is running in a testing environment? Well, we can. And we can do this by making use of what's called an interface. Imagine that our process payment function contains an outlet with a specific shape, and other objects matching the shape could plug into process payments outlet. In code, this shape is represented as function signatures, and as long as other objects implement functions that match those signatures, they can fit into process payments outlet. So we can move the code in process payment that calls the Stripe SDK to its own structure that we'll call Stripe. This structure will implement the method signatures defined in the interface. Now the stripe struct conforms to the shape of the outlet. We'll then attach this interface, which we'll generically call payment gateway, to the process payment function. We'll get into how this enables us to plug in different objects for different environments in a sec. But first, let's remove the last Stripe SDK specific dependency from our process payment function. That is the customer type that is provided by Stripe. We can actually just create our own user struct and use that in its place. This structure will simply contain an ID and an email for a given user. We'll also want to remove Stripe's dependencies from the transaction returned by our process payment function. And now we're left with a function that's completely decoupled from Stripe. And this is going to enable us to unplug it when we need to. Now remember, our function now provides an outlet for other objects to plug into. So if our testing mock gateway conforms to the shape of our outlet, or in other words provides implementations for the functions defined in the payment gateway interface, it then becomes compatible to plug into the process payment function. So in our test, we can plug in the mock gateway when calling the process payment function, and like magic, we can test the process payment code without calling live Stripe APIs. And there's a bonus. Now that our code isn't tightly coupled with Stripe's SDK, if one day Stripe decides to raise its fees by an unreasonable amount, we can just unplug them and switch to a new payment gateway that provides better fees, like Square for example. So that's the second law. Decouple components by making use of interfaces where it makes sense to do so. Now for the final law, you'll notice that our function in its current state has two responsibilities. It processes the payment, but it also does some calculations to subtract a hold amount from the payment for fraud prevention. So if we want to test those fraud prevention calculations, we'd actually have to call the entire function and extract the amount from the return transaction to test that the calculations were applied correctly to that amount. But what if we could test this portion of the function in isolation? If we extract this calculation to subtract the hold amount to its own function, and then call it from within process payment, we're now able to create a separate test specifically for the calculations. Which brings me to the final law. Separate functions into individual responsibilities where it makes sense, as this helps to modularize and simplify your tests. And that's going to be it for this video. If you found it helpful, don't forget to leave a like, and I'll see you in the next one.